The AI boom is obviously here. I mean, every single day we see these models getting more powerful, writing code, creating unbelievable art, and just changing the world. But behind all of this incredible progress, there's a massive, kind of hidden problem. And it's a problem of scale that could stop this whole revolution dead in its tracks. So let's get into it.
So what's this big problem? Well, it all comes down to something called the AI scaling dilemma. And it's actually pretty simple. Our AI models are amazing, but they have this giant, completely out of control appetite for resources.
So you gotta ask, right? Are these modern AI models just getting too big? And the short answer? Oh yeah, absolutely. And we're not talking about a small issue here. This is a huge wall that's basically deciding who gets to build and use the most powerful AI.
Just to put this in perspective, look at this number. 26 gigabytes. That's how much memory you need just to load a pretty standard model like Llama 13B. I mean, that's more RAM than a lot of high-end gaming laptops even have. And that's just to turn it on, not even to do any real work.
Right. So this size problem, it just snowballs. It makes AI insanely expensive to train and run. It's a massive power hog, which is a real environmental concern. And maybe most importantly, it means all this incredible power is stuck in these giant data centers, locked away in the cloud and pretty much controlled by just a handful of big companies. That's the dilemma we're up against.
Okay, so how do we fix this giant problem? Well, what if the solution is kind of obvious? What if we could just shrink the AI's brain? You know, take that huge 26 gigabyte model and somehow make it tiny, but without it losing all its smarts. The secret sauce here is a process called quantization. Now, just think of a model's brain, its parameters or weights, as this giant, super detailed palette of colors it uses to think. A normal model might have like millions of different shades. Quantization is basically the process of simplifying that palette. So instead of millions of colors, what if it only had a few hundred? Or what if we got really extreme and it only had two?
And you can really see the difference here. On the left, you've got that full precision model. It's like a beautiful, full-color photograph. Tons of detail, but it's massive and slow to process. But on the right, that's 1-bit precision. It's basically black and white. The memory it takes up is tiny, and the math becomes ridiculously fast and simple. But, and this is the big question, how do you get a model to think in just black and white without, completely breaking its brain?
Because, as it turns out, how you shrink the model is everything. There are basically two ways to do it, a dumb way and a really, really smart way. Okay, so the first method is called post-training quantization, or PTQ. This is kind of the brute force approach. You take a fully trained, super smart model, and then you just squeeze it into a smaller format after it's already learned everything. The smarter way is quantization-aware training, or QAT. With this one, you teach the model from the very beginning to work with these limitations. It basically learns to think in black and white right from birth.
And the difference in the result is night and day. I love how the source material puts it. Trying to force a model that learned with a full color spectrum to suddenly see only in black and white, it's like subjecting it to brain damage. The performance just falls off a cliff. It's often catastrophic, because the model just has no idea how to handle that massive loss of information.
So that leads to the crucial question. If we use the SMART method, the quantization-aware training, can we actually build a powerful AI that thinks in just ones and zeros? Well, this is where we get to the big breakthrough.
And here it is, meet BitNet. Researchers have basically taken that QAT idea and run with it. They've created a whole new kind of model that's designed from the ground up to be super tiny and efficient. And it's really the first solid proof that this crazy idea of extreme 1-bit quantization can actually work in the real world.
The magic behind it is something called the bit linear layer. And just look at how simple and elegant this is. Instead of using all these complicated decimal numbers for its calculations, BitNet only uses 3 possible values, -1, 0, or +1. And what that means is it can completely ditch all that expensive multiplication. All the math just becomes simple addition. For a computer, that is unbelievably faster and way, way more energy efficient.
Okay, so just how much more efficient are we talking? Well, the numbers are kind of staggering. Let's compare BitNet to other models of a similar size. Look at its memory footprint for its core weights, just 0.4 gigabytes. That's more than 10 times smaller than mini CPM. And its latency, how fast it responds, is more than twice as fast as its nearest rival. I mean, these aren't tiny little improvements. This is a genuine leap forward.
But here it is, the million-dollar question. All that efficiency is great,
But does it make the model dumb? And this right here is the punchline. Just look at the overall average performance. It's almost identical to the full precision model. Yeah, it's a little behind on some things, but on math reasoning, it's actually better. It's giving you pretty much the same brain power with just a tiny fraction of the resources. That's huge.
And what this all points to is something really profound, a totally new scaling law for AI. See, the old rule was pretty simple. To make an AI smarter, you had to make it bigger, which always made it way more expensive. But this new rule says we can actually make up for that lost precision for thinking in black and white by just adding more of these super cheap parameters. We can build models that are way bigger and smarter, but for the same cost.
So, okay, that's the tech. But what does it actually mean for us in the real world? Because this isn't just about data centers and research papers. This is about putting powerful AI, well, everywhere, for everyone.
So what does this mean for you? Well, it means having powerful AI that runs right on your phone or your laptop, not in some faraway data center. It means having an AI that works instantly, even if you don't have an internet connection. It means real privacy, because your personal data never has to leave your device. Think about it. No more lag, no more subscription fees just to use a smart assistant. This is the kind of tech that will put truly powerful AI in your pocket, in your car, in your glasses, all around your home.
And that brings us to this final big idea. For years, we've just assumed that powerful AI and giant centralized data centers were two sides of the same coin. You couldn't have one without the other. But these one-bit models, they're starting to break that link. So if AI can finally leave the cloud and live right here on our own devices, the question we're left with is, what happens next?